Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 7. It says in the circuit diagram below, the potential difference across the terminals of a battery is 12 volts. Note, we are given the potential difference across the terminals of a battery, right? So that means in other words, we are given the external voltage. So the 12 volts there, note it is not the EMF, it is the external voltage. And then looking at where it is indicated here, we can see that it is indicated just directly to this battery. So that means this 12 volts is not inclusive of the V internal that will be taken as a result of the internal resistance, right? So when the current flowing is 1.2 amperes, so the 1.2 amperes, that's our total current. We do understand that it is connected closer to the battery. The battery has an internal resistance of 1.5 ohms. The resistance of the ammeter and connecting wires can be ignored. Then in 7.1, they say calculate the resistance of the external resistors in the circuit. Now, judging from this, we are already given the total current, and then we also have the V external, meaning we can get the R external, right, which is the external resistance. So to calculate this one is just straightforward. It's R external is equals to V external over the I total. So it's taken from the formula that you know, R is equals to V over I. Now our V external, that's 12 volts divided by the current is 1.2 amperes. Now having to do that, you get 10 ohms, right? So that's essentially how you would tackle 7.1 for only 3 marks. So formula, substitution into the formula and correct answer with the correct SI unit. Okay, so now let's proceed to 7.2. So in 7.2, they say calculate the resistance of resistor R. So note that these ones here, the parallel, are in parallel, meant to say the 4 and the 6 ohm resistor. Then we have resistor R here, which is, we can all see it is connected in series. Now remember, in order to calculate R here, we must remember that the R external is the sum of the R parallel plus the R series. From the previous question, we already know what's the R external, 10 ohms. So that means we would need to calculate the R parallel so that we can then calculate the R series. So R parallel is equals to R1 multiplied by R2 over R1 plus R2. So I'm using the product over a sum formula. So that's 4 multiplied by 6 over 4 plus 6, and then I get 2.4 ohms. But then remember, having to substitute into this formula, if R external is 10, then my RP 2.4, and then my RS is just resistor R. So obviously at this point I must say 10 minus 2.4, and then I get my resistor R is equals to 7.6 ohms, right? So that's how you could have tackled that one. Quite easy, right? Then for this was 7.2, so let's indicate. Then to calculate 7.3, let's proceed. So for 7.3, they say now determine the EMF of the battery. So you see now they want us to calculate the EMF, which indicates that the 12 volts here is not the EMF, right? So the 7.3, its E is equals to the current, bracket R plus R, right? So we know this is the formula to calculate the EMF of the battery. Now our current, we are given there, we use the total current 1.2. Then this R here is for the R external, right? So with the R external, we did calculate in 7.1 is 10, and then plus the R internal, right? So 1.5. Now all you do is just grab your calculator, aka umshini weibalo, and then just punch all of this into your calculator. Then you get 13.8 volts, right? So it was a pretty interesting question. Then okay, now to now look at 7.4, it says a resistor of 2 ohm is connected between point X and Y. So that means now we have a connecting wire here, and then whereby we need to then calculate our connect our 2 ohm resistor like this. So if we are to connect a 2 ohm resistor between point X and Y, then we can see that we now have 3 resistors that are now connected in parallel, right? Now they're asking, how will this affect the ammeter reading? Answer by writing only increase, decrease, or remain the same. Now, what I prefer with this question is that first I try to explain this, and then I can decide on the answer. So remember, when they're asking about the ammeter reading, that's mainly the current. What will happen to the current? Because the ammeter measures the current. So now we can see that these resistors here are connected in parallel. And then we know that adding a resistor in a parallel connection, it decreases the total resistance. So if you keep on adding more resistors, because we are using the formula 1 over Rp, if you keep on adding more resistors here, then what essentially happens is that your Rp becomes smaller, right? So the more resistors you are adding into a parallel connected circuit, you are decreasing the total resistance. So when the total resistance decreases, because R is inversely proportional to current, we know that a decrease in the total resistance will result in an increase in the total current. So how do we explain this? Let's put it in point form, and then let's see how best we could have explained that. So the solution is supposed to say increase, the current will increase obviously. Then the explanation is that adding a resistor in parallel decreases the total resistance. R is inversely proportional to I for a constant V. Then a decrease in total resistance will result in an increase in the total current. So when you explain, I always always made you know that you must use the ORC method. So you tell us the observation, the relationship, and then the conclusion of the matter. So that's how you were supposed to go about answering this question for a total of 13 marks. So hope you enjoyed the lesson. And then if you have found it helpful, please press the thumbs up button. If you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.